Welcome back to the workshop. We want to continue taking a look at section 3.2, probability distributions. And in this video, we want to consider the distribution function. So we looked at the probability distribution, which is a function. And in this video, again, we want to look at the distribution function. So what's the difference? Well, the difference is that the distribution function also goes by a different name called the cumulative distribution function. And so for this, we're actually looking at the distribution or the probability of some event or any prior occurring or any lesser. So let's take a look at that. So a distribution function is, well, if x is a discrete random variable, of course, that's the one that we're discussing. The function given by capital F of x is equal to the probability that the discrete random variable takes on any value less than or equal to x. And if we define it that way, then we can realize that we're just looking at the sum of all of the probabilities for each possible outcome or for each possible value of the random variable, which is less than or equal to x. Okay, so f of t is the value of the probability distribution. All right, so again, it's this capital F is called the distribution function, or maybe a little bit better known as the cumulative distribution function. Okay. All right, so let's find the distribution function for the probability distribution given in our first example. So in our first example, we considered, again, that example of the couple having 3 kids. So our possible values for the discrete random variable were 0, 1, 2, and 3. So we just want to find the associated values there. So we have capital F of 0, capital F of 1, capital F of 2, capital F of 3. So 0 is the lowest value that we can take on. So the sum of all the probabilities from 0 and below would just be the 1/8, the probability of having 0 girls. F of 1 would be the probability of having 0 or 2 girls. Sorry, 0 or 1. 0, 1. There we go. 0 or 1 girls. And this is equal to, notice that this is f of 0 plus the probability of having 1. So this would be 1/2. Here, f of 2 is the probability of having 0, 1, or 2. So this would be 1/8 plus 3/8 plus 3/8. And I think it's worth pointing out that this is the same thing as f of 1. So it's 1/2. 1/8 plus 3/8 is 1/2, plus the 3/8 for the probability of having 2, which overall gives us 7/8. F of 3 then is the probability of having any one of 0, 1, 2, or 3 girls. So of course that's 1/8 plus 3/8 plus 3/8 plus 1/8, the probability of having 0, 1, 2, or 3 girls. It's worth pointing out that this can be written as f of 2, which was 7/8, plus the probability of having 3 girls. And of course, those are our only possibilities, or those are all of the possibilities, returning back to the previous theorem. That is the sum of all of the probabilities. And of course, by this theorem, it has to be equal to 1. And that is what we find here. 7/8 plus 1/8 is in fact 1. So that's good. So a couple of things to note here. So note. For x less than 0, f of 0 would be 0, because we cannot have less than 0 girls. Okay. Now, if we consider f of, let's see here, sorry, that should be an x. If we consider x greater than 3, f of x would have to be 1, because the probability of having fewer than more than 3 girls, right? So the probability of having fewer than 4, the probability of having fewer than 5, of course that probability is 1, because we're either, the only possibilities are 0, 1, 2, or 3. Okay, those are our only possibilities. So if you say, well, what's the probability you're going to have fewer than 10? Of course we're going to have fewer than 10. It's not even possible to have more, okay, in terms of if you're only having 3 kids. So with this idea, this is essentially what happens to our probability, our cumulative distribution. And we can graph that. It's worth taking a look at. I don't think it's the most important thing, but it becomes a little bit more important in our next video. So let's take a look at this. What would the graph look like? We want to utilize this. And when we graph it, what we actually do is we utilize, let's see here, 0, 1, 2, 3. We don't give it as just the points above. We don't give it as a bar chart or a histogram or anything like that. What we actually do is we say, all right, we're just going to give it as a function, right, as if the inputs were real inputs as well. So let's say this is 1/8, so 1/2 is here-ish, 7/8, and 1. So our probability for less than 0 was 0. But the probability at 0 was 1/8. And then it stays that until we get to 1, and the probability of 1 was 1/2. Right, 1 or fewer. The probability of 2 or fewer was 7/8. And the probability of 3 or fewer is 1. So this is what our graph looks like. It's a step function. It takes a step up, stays the same, takes a step up, stays the same. So this is called a step function. And this is good, okay? This is fine. These are the only values that we're actually concerned about. But again, in our next video, these additional notes or observations will be important. All right. So let's also find the distribution function for the probability distribution that we, again, looked at in the previous video. So this one takes on an infinite number of values, so I can't simply find f of 0, f of 1, f of 2, f of 3. I can't actually continue on for forever. And of course, we actually don't have 0 in there, so it's just these ones. I can find these individual values, and that would be a good idea. This is going to help me identify what I should get in general. So f of 1, actually, let's just go ahead and get rid of all of that there. And f of 1 is simply f of 1, which is 1 over 2. Okay, excellent. F of 2 is going to be f of 1 plus f of 2, lowercase, that is. So that's going to be 1/2 plus 1/4, which would be 3/4. F of 3 is going to be 1/2 plus 1/4 plus 1/8. Of course, we can recognize this as 3/4 plus 1/8, and that would be 7/8. And if you see a pattern already, that's fantastic. Let's take a look at just a couple additional values to see if we get the idea. So f of 4 is going to be 1/2 plus 1/4 plus 1/8 plus 1/16. And this would give us 15/16. And f of 5 would be equal to, emphasize this a little bit more, this is going to be f of 4 plus f of 5, So 15/16 plus plus 1/32, and that would be 31/32. Excellent. So in general, f of x is going to be, what does this look like? Well, this is 2 to the first with 2 to the first minus 1 in the numerator. This is 2 squared with 1 less than that in the numerator. This is 2 cubed with 1 less than that in the numerator. This is 2 to the fourth with 1 less in the numerator, and 2 to the fifth with 1 less in the numerator. So this is always going to be 2 to that power in the denominator, and then in the numerator, 1 less than that. And that's it. Easy enough. All right, and that should be, that's saying that's done by observation is fine. If you wanted to create a generic formula, of course, you could do that as well. All right. So that is the distribution function for this particular probability distribution. Excellent. That's all that I have for this video. Again, maybe you want to notice that if we were to consider values less than 1, then the cumulative probability would be 0. And well, and we'll look at what happens as we continue to go higher in our next video. So thank you for your time and attention. I'll see you guys back in the workshop very shortly.